All right, so the first thing we're going to learn about is called the double straight edge conjecture. Let me try, this tool seems to work better with, where's that tool that changes it into letters? This is called this thing. Or this is called the double trouble. Double straight edge conjecture. Because it's waiting for me to finish. That's why it's called a smart board. It's very smart. Whoa! Isn't that cool? Okay. So this is called the double straight edge conjecture, and I practiced this last night. So I'm going to try to get this right. So what it says, if you take a straight edge of any side, so I'm going to take my tool, get my ruler, my ruler, which ruler do I want? 20 centimeter, why not? Okay, so here's my 20 centimeter ruler. I'm going to take my straight line, and I'm going to try to draw a line from here to here. Right? Draw a line from here to here. I'm sort of tracing, sort of cheating. And then I'm going to draw a line from here to here. And then I'm going to move my ruler, which I can do. I'm going to turn my ruler at any angle close. Come on, folks. It works good. There. I want to turn my ruler at any angle that I want to turn it. I'm going to move it over here. And then I'm going to trace again. And so I'm going to trace from like here to here. And then I'm going to trace from here to here. Oh no, stay there. Come on. Work. Oh. What happened? Where'd that other line go? Oh, there it is. Okay. Okay. And now I'm going to take away my ruler. So I can close my ruler. What does this thing appear to be in here? Not just a parallelogram. A diamond. What do you call a parallelogram where all the sides are the same? That appears to be a rhombus. Right. That appears to be a rhombus, and that's exactly what it is. And we will prove that later on, okay? But what that says, so the double straight edge conjecture, if you go to my website, well, look at this, and you go to Geometry Assignments Chapter 5, and you go up here, here's my conjecture. And the double straight edge conjecture, which you should have somewhere on your sheet. Which number? 49. So what it says, double straight edge conjecture. If two parallel lines are intersected by a second pair of parallel lines that are the same distance apart as the first pair, then the parallelogram formed is a rhombus, okay? And that's what goes in there. How do I write it? I know it's not letting me write. Oh, there. Look, I could even go there. I bet I could get, watch this, is a R-H-O-M-B-U-S. Does that work? No. It's a rhombus. Look at that. Right? It's a rhombus. So that's what you could write as a double straight edge conjecture. Now going down back to my rhombus diagonals conjecture, the diagonals of rhombus are blank and they blank each other. But diagonals are a rhombus are friends and they love each other. No, that's not what goes there. I'm just kidding. So going back, where did we go? Where was that picture? Diagonals of a rhombus. So now if I drew in the diagonals, I'm going to get those arrows out of here. Okay? If I drew in the diagonals in red this time. What's so funny?
I'll tell you later.
What appears to be true about the diagonals of a rhombus? Who wants to raise their hand and tell me? Yes, Sam.
They are perpendicular and they bisect each other.
Perfect, okay? So what Sam just said is exactly right. They are perpendicular, okay, meaning all those angles right in there are right angles, and they bisect each other, okay, meaning they cut each other in half. So that's congruent to that, and that's congruent to that, and that's congruent to that. Yes?
So wait, are those isosceles triangles or no?
Are these, yes, of course, they'd have to be isosceles triangles.
No, they're not. Yeah,
Yeah, because if this side is congruent to that side, which they are in a rhombus, right? Then they have to be isosceles triangles. And that is also the way you can prove that these triangles, that this makes 90 degrees. We'll get there. But because these are congruent, that makes these base angles over here congruent, right? So this angle right here would have to be congruent to that angle there, right? Because it's an isosceles triangle. On this side, oh, that's angle side. So, but I could show that this angle would be congruent to this one because it's a parallelogram, but those are in different triangles. Oh, you could use the vertical line? No, you couldn't use it. You would have to show that this triangle is congruent to this triangle, and then that this triangle is congruent to this triangle, and then you could use our corresponding parts to show that these triangles are congruent. But we're not going to go there yet, but on Black Day we'll do something. So that's what that next conjecture says. C50 rhombus diagonals conjecture, the diagonals of a rhombus are perpendicular. Okay? Perpendicular goes in there. So you can type that as well as I can, right? Pretty good, huh?
Wow. Fancy.
They're perpendicular and they bisect each other. Ooh, I like this. This is fun. Okay? And they bisect each other. So now you got that one. Right? So that's the next conjecture. Now, so the next thing that we're going to talk about is C51. The rhombus angles conjecture says that the diagonals of a rhombus length the angles of the rhombus. What do you think that should say? Hello? Yes, that's what it should say, is they bisect the diagonals of a rhombus. Where was my picture? Going back. There, whoops, maybe I have to go forward. Okay. So, because we just said that this thing and this triangle, you could show pretty easily that this triangle here would have to be congruent to this triangle here because of side, right? Side, because they share a side. Therefore, this angle and this angle would have to be congruent, right? And this angle and this angle. And therefore, the diagonals bisect the angles of the rhombus. Now, that's not true for any old parallelogram, right? It's just true for a rhombus. And so just in a rhombus, these angles are congruent, these angles are congruent, these angles are congruent, and these angles. Okay, moving on to what's next. Rhombus angles, we did that. Rectangles, diagonals, conjecture. Oh no, are we here or we're here? Diagonals of a square, that's boring. Okay. Rhombus, angles, conjecture, diagonals of the rhombus. Rectangles, rhombus angles, we did that. C52, diagonals of a rectangle. That's pretty easy, isn't it? What do you think about the diagonals of a rectangle? Are they? Do they look perpendicular? No. Okay. Who could tell me what appears to be true about the diagonals of a rectangle? Yes, Kevin. They bisect each other, that is true. That could be proven pretty easily. So this piece is congruent to this piece. And furthermore, all four of those pieces are congruent.
So they create
They create
Four triangles, which are not, but what about the length of this versus the length of that? They're the same, okay? So those are the two words that should go in that conjecture.
But they don't bisect the
Okay.
angles, right?
They do not bisect the angle. So going back here, rectangle diagonals, the diagonals of a rectangle are congruent, not equal. We say congruent. This is fast because I'm a good typer. Okay? Congruent, right? And, going over to the next thing, and they do what? They bisect each other. And that's that one. Okay?
What was the rhombus one?
The rhombus angles, that the diagonals of a rhombus bisect the angles of the rhombus. Okay? And then lastly, so this is something I normally like to discover, but we're kind of interrupted here. So square diagonals, since a square is a rectangle, okay? Since a square is a rectangle, and a square is also a what? A rhombus, then it has all the properties of both a rectangle and a rhombus. So the diagonals of a square are congruent, right? I messed up. Now I'm erasing things over there. Are congruent and what else? And are perpendicular and bisect, right? So they do all those things. They're perpendicular, they bisect, and bisect each other. But you should also say they're perpendicular, right? Is that the last conjecture? Let's see.
There's 3 spots.
Oh, there's more spots on your paper? Okay. It says the diagonals of a square are congruent, perpendicular, congruent. Oh, that should say perpendicular. Perpendicular. Ooh, I like this. And bisect each other. Okay? And that's kind of all you need to know. And your homework for today is, hey, yay, that's it. Wait, your homework for today is, okay, nothing. Page 290.
15, 17 through 27.
1 through 15. And the first 10 are just matching, okay? So don't say, oh, that's so much, I can't do that. I have to take care of my sister tonight. Okay? Or whatever. And that's it. And remember, you heard it here on Mr. Leader's YouTube channel. Goodbye.